Hey everyone, welcome back. This is Christian Ramirez. So today's demo is about API hooking. And I know what you're thinking. Hooking is what APIs and EDRs do. It's a defensive thing. Yeah, you're right. It is, but what I am going to show you today is exactly the same mechanism defenders use to watch while we are doing it, but in an offensive way. So we will be able to pull credentials straight out of our running process. We are going to cover just enough theory to make it make sense, and then I will show you GhostHook, a new tool that we developed. So hidden a password manager live, showing how we can exfiltrate the master password to our C2. A quick roadmap of what we are going to cover. We will start with a fast recap of how hooks were actually built, trampolines, detour, the E9 jump, opcode, just enough to understand the demo. Then the fun part, the light demo, and where we are going to hook a password manager dialog and watch the credentials show up in our C2. Then, if you stay to that part of the video, we are going to dissect and how the tool works and show you that hooking is not just for defenders. Red teamers can hook too, the same mechanism, different goal. And finally, after that, we'll walk you through GhostHook and how it's structured and how the attack flows. So, all right, let's get into it. Um, let's start a little bit of recap. What is API hooking? Right, so API hooking is a technique where we intercept calls to Windows API function by patching the function's first bytes in memory with a jump instruction. Execution gets redirected to our routine before the original function ever runs, right? That's it. Basically, it's patch the bytes, redirect execution, intercept the call. Everything else is we are going to talk about is built on top of that. But why does any of this exist in the first place? So what problem is the defenders try to solve, right? So let's talk about a little bit about that. So it's about visibility, right? So Windows APIs like virtual log, create thread, write process memory, those are the gateways to anything dangerous. But by default, the antivirus or EDRs has zero visibility into what is happening inside the running process, right? They are blind basically. So they have two different options. Number one is user land hooking. That basically is where they inject into every process, patch the first bytes of the, for example, the NTDLL export, and now every sensitive API calls detours through vendor expectation code before hitting the kernel. Right, that is the most common approach. The second one is the kernel telemetry drivers. The PS set create process notify routine, callbacks, ETW, no injected DLL, no userland patches. Everything happens at the kernel level. By the way, if you want to learn and check if your antivirus or EDR is using these techniques, we released a previous demo video called API hooking, analyzing antivirus EDRs. So anyway, this is exactly what we are going to do today. So we are going to about to use API hooking technique to steal the master password of famous password safe software. So let's go to the demo, right? And for that, and basically the demo is where we are going to do this, right? So we're going to present GhostHook and our Trojan infostealer. This is what it's going to do, the injection, the hooks, and the exfiltration. So let's jump to our VMware machine, full environment, and let's see them practice. In here, we have our environment. So I'm going to adjust the things in here. Okay, this is the password that we are going to use. And as you can see in here, and the password manager, password safe is running. So in here, there is nothing, right? And the jet is clean. So, and this is the password that we're going to use. We are going to copy. We are going to open it. And this is our GhostHook. We are going to execute it, right? And once it has been executed, so we are going to copy and paste the password. And we are going to open our vault. You can see here is the password. I say click, and the password safe has been opened, and we can see the secret right in here. So just we can do edit entry, whatever, right? We can see the password, right? But if we go back to our C2 infrastructure, we can see that we were able to exfiltrate not only the password, also the database path, the process, the name of the computer, the user, right, the IP. So, and again, if we just come here and copy this password just to make sure that is the right password, we can copy it and we close password safe. We reopen it and we show it, and it's open again, and we cut again request, and also we save, we create a file that contains the password, right? So now let's go back to our presentation and let's explain the actual hook flow, right? So basically, and that is divided in 8 different steps. So the first one is the loader has already injected our shellcode blob into the password safe process, because we are using a technique called shellcode reflected DLL injection. So basically, the DLL self maps entirely in the memory, no files, no DLL on this inside the process. So the DLL main fires and is where we live, right? The second stage, and here second step, is basically where we first the hook goes, right? Detour attach and to our target API function inside, for example, kernel 32 DLL. The detour save the prologue bytes to a trampoline, and this is where we write the E9 jump instruction at the byte 0. Every call to that API now comes through us, right? So that is the function handling the master password input. As a third steps in here is basically as the second hook, right? So a hook where we are going to monitor it, and is the one that is watching for any files open with the bold extension pwsafe. Why is because we want to know which bold just go unlock. The database path basically goes to our beacon, right? This is the exactly what we are seeing in here. The path of the PSA safe tree, right? The next steps is basically uh, we uh, we use open the master password dialog. The password safe render is normally. Nothing looks wrong, but now every character that the user type is routing through our API that was hooked, right? Which we already own. Step number 5 is basically here one. So here is where a fires the user hits enter, and then we hook and intercept the call. So we call the original function through our trampolines. The apps keeps working perfectly fine, and we read the output of the buffer. That basically is the password in plain text right in memory. As a step 6, we don't just blindly grab everything to the hook. So the hook that was fired before. So we notice that there is a lot of garbage, like environment variables, register path, all kind of noise. So we filter out the password, right? And this is exactly how we get the password and exfiltrate it. Step number 7 um, basically is we write to a local log the file that we saw in here locally that contains the password, right? And also we exfiltrate via the network and to our C2 framework. That is exactly what we got the password and everything here via network and in JSON format, right? So and basically it will contain the password, the computer name, the username, the process name, the ball path, right? And then yeah, and step number 8 basically is here. So it's in here what keeps us invisible is our hooks return the original and the API return to the value, right? And unchained through the trampoline. So basically the application gets exactly what is expected. The pwsafe.exe unlocks, the user goes about their day, and we have the master password. So basically, we are returning the execution flow to the original API call, right? And as you can see in here, all these 8 steps, all are in memory. Nothing on this process behaves normally the entire time. So this is GhostHook in a nutshell. So let's jump to the next slides. If you had been at this point in the video, so now we are going to explain a little bit more about trampolines and hooks. Let me talk about the 3 main ways to hook an API because it's not just one technique. The first one is called Detours style trampoline hooks, right? This is what GhostHook use. We override the target function's first byte with the jump to our hook, right? But Detours save those original bytes into a trampoline stuff first, so we can still call through the real functions. The target process has no idea anything will happen, right? The second flavor is called import address table hook. Instead of touching the function itself, we go into the import address table and replace the pointer. The original function code is completely untouched, so we are just changing who gets called. And the third one is called inline patching. The hand roll version. No library, no detours, just us manually writing our jump and trampoline logic. It has pros and cons, maximum control, also maximum risk of getting it wrong. So yeah, all 3 ended up in the same place, our code running in the middle of someone else's code. They're just different in the and where and how we intercept, right? Now, specifically detours, right? Microsoft Detours takes the original function prologue, saves those first n bytes into a trampoline stop, then writes the E9 jump at the byte 0 pointing to our hook. Our hook runs, calls back through the trampolines to the real function, gets the result, right? Um, does whatever it wants with it and return the original value. Right, so the target never knows. The tools handle the Win API calls and the prologue is saving automatically, right? And they basically that is the whole game. And as you can see here, so we are using the Microsoft Detours and the framework, right? And basically is what it does. Let's move on to our next slide. And in this one, we are looking at what defenders are doing. Hook DLL injected into every process. For example, NTDLL export and patch with the E9 jump instruction, right? Arguments inspected before that they hit the kernel. Now look at what we are doing. Literally, the exact same E9 and jump trampoline. The difference is not the mechanism. The difference is the goal. Instead of inspecting the malicious behavior, we are going to steal data, right? And we can target anything with this password dialog, clipboard APIs, crypto routines, browser input handlers, anything that pass interesting data through a Windows API, right? The stealth advantage here is significant. Our hook lives entirely inside the target process that's on the memory, right? So no new process spawn, no suspicious parent-child relationship. We are just here, blending it. And as you can see in the demo that we showed, the target was the master password input inside the password safe. Basically, and with one hook, one API, we own the ball, right? And as you can see in the demo, so it's basically what we did. We hooked the master password input inside the pwsafe.exe. We capture the credentials in a txt file locally, and also we exfiltrate all the information to our C2 right command and control server. Right. So let's move on to the next slide. So basically in here we are going to talk about GhostHook, the attack overview. And we target the password safe, a very popular local password safe manager. It protects the entire credential vault behind one master password, a high value single point, right? It's ideal target. So the technique is basically we hook the password dialog input function. Every character that the user type routes through the API, we are sitting right there in the middle, right? So we deliver it with a shellcode reflected DLL injection, also known as sRDI, right? So we don't want a DLL dropper on this inside of the target process. That is very noisy. So our Steler DLL gets converted into a position independent shellcode using this technique called shellcode reflect DLL injection, and injected directly into the pwsafe.exe, right? It self-map entirely in memory and nothing on this. So basically, our GhostHook tool has three components, right? So we have the GhostHook DLL, right? That basically is the Steler DLL, install the hooks, capture the master password, the beacon JSON, the C2, and over HTTPS, right? So we have our GhostHook bin that basically is our position independent shellcode that's self-map and run the DLL entirely in memory. And we have our injector, right? So that basically decrypt our shellcode, find the target, the pit, and inject it into the process. In this case, the process is pwsafe.exe. And for that one, and we can use some sort of injection technique, right? Yeah. So if you are finding this content useful, please subscribe so you don't miss the next demo. We have got more coming. Jump into our Discord too. Links is in the description. It's a good place to ask questions and connect with people working on the similar stuff. If this technique was interesting to you, share it with your team, your security community, anyone who wants to go deeper on offensive development. It really does help us keep making content. See you to the next one.